testing crayfish resting membrane has made many advances in science. Resting potentials are the ultimate determinants of the activity and the lack of activity in the cell. Negative 70 millivolts is the average resting potential we expect to see in a normal crayfish. In our study, we used 3 crayfish to test the resting potential. You know that the more positive the resting potential is, the easier it is for an action potential to fire. The more potassium that's in a resting potential makes the resting potential more positive. In our study, we tested crayfish resting potential in Aquafina, 5.4 millimolar saline solution, Mountain Dew Kickstart, and Gatorade. We wanted to look at how sodium and potassium play a role in the overall resting potential. Studies in the past have showed us that a higher potassium increases the resting potential of a cell, which was performed by Taylor and Jenkinson, and Brindley and Mullins also found that energy drinks have a lot of electrolytes, which contain a lot of potassium and sodium, so we were interested in seeing how this would affect crayfish. So, in our study, we hypothesized that Mountain Dew will have the largest effect on resting potential, and water will have the smallest effect on the resting potential of crayfish muscle cells, based on the fact that Mountain Dew contains the highest concentration of sodium and potassium, and purified water contains neither sodium or potassium. And our dependent variable was the resting potential, and our independent variable were the solutions because of the concentration of sodium and potassium.
So, first, there's 3 crayfish. Oh no, for 10 minutes. Numb your pain sensors. Cut off the tail. And remove the swimmer heads. And you remove the superficial muscles. The superficial muscle covering in order to reduce the muscle. So that we could use an electrode and hook it into the muscle in order to measure the resting potential in millivolts. So we used 3 different crayfish tails in this experiment. The first one we used in saline solution as a control, then the second one we used for both water and Gatorade trials, and the final tail we used for the Mountain Dew Kickstart trial. After we placed the tail in a dish with each respective solution, we waited 2 minutes so that the cells would have ample time to soak up the solution and the resting membrane potential would actually be effective before we measured it. We chose these 3 specific solutions due to their levels of sodium, potassium, and cadmium.
Hello! Alright, so membrane potential in muscle cells was significantly altered by the solution in which it was soaked. Here's Patrick with the means. The mean for saline was negative 36.67. For Gatorade, it was negative 22. For Mountain Dew, negative 31.67. And the mean for water was negative 98. When compared to saline, Gatorade increased membrane potential by 59.99%. Mountain Dew Kickstart increased membrane potential by 86.36%. And water increased membrane potential by 267.24%.
Oh, hey there. So our hypothesis was supported by the data from our findings, which is pretty cool. And what we found was that membrane potential became more negative when muscle cells were soaked in all of the drinks compared to when they were soaked in saline, which was our control. Water caused the largest change when compared to the resting potential of saline, followed by Gatorade, and then lastly Mountain Dew, which that was contrary to our second hypothesis where we suggested that Mountain Dew should cause the largest change. Basically, water caused the most change. When we look at the negativity of a resting potential of the cell membrane. However, water made it the most negative. Therefore, water actually was our substance that made the cell least likely to create an action potential, since action potentials rely on the cell becoming more positive or less negative. Therefore, Gatorade actually made the cell, or put the cell in a position where it would be most probable that an action potential would occur. Basically, soaking the cell in Mountain Dew as well as Gatorade created a more negative, or a more positive membrane potential for the cell, which allows action potentials to fire more readily. There were a couple limitations of our study. I know, hard to believe. But, so our study was limited by only using one crayfish tail when we were soaking it in Gatorade and as well as water. We used one tail independently for saline, one tail for Gatorade and water, and then one tail independently for Mountain Dew Kickstart. So there was tons of room for contamination as far as soaking the same tail in Gatorade and water, even though we gave it that 2-minute time block in order to soak in the liquid. Even more than that, we used the same Petri dish to put the tails, every single tail in, so without washing them out in between trials. So basically there was also a chance for contamination when we would dump out a solution and then pour another solution in there without that cleaning process. We do find that our findings are consistent with past research, and encourages looking into what food and drinks actually do for our bodies. So we hypothesized that Mountain Dew would have the largest effect on the membrane potential, which it didn't, water did. But we also said it would be because of its potassium and sodium concentrations. But that didn't seem to have as much effect as maybe something else did. So it leads into the idea that maybe we should look into what other aspects of food or drink encourage entrance of those compounds into our cells. And also it maybe leads us to think what would happen if we did the same study but with substances that were advertised as relaxing, so such as like medications or teas or incense or some sort of essential oils. Yeah, there are lots of things that could arise from our findings and other people's findings, so we'll just have to see what the future holds.